right, moving on. We're going to continue with triangles. We went through homework yesterday and problems yesterday. So hopefully you have a better understanding of law of cosines. Today we're going to continue with what is called law of sines. Which is another way of being able to manipulate through triangles. Which tends to be a little bit easier than law of cosines. But the basis for the law of sines and why it works, we have to start out with respect to finding and calculating the area of a triangle. Thank you, everybody. Question is, how do we calculate the area of a triangle? How do we find the area and calculate the area of a triangle? Kicks back into our geometry days. Okay, 1/2 A times B, which is called a base times height. So we have our area is equal to 1/2 times our base times our height. Okay, 1/2 times our base times our height. Now the question is what is our definitions? Because like I said before, everything in mathematics, you can go back to definitions. Okay, what we have to define is what is a base and what is a height. Well, base is any side of a triangle. We have embedded in our brain, when we talk about a base, most of the time the definition that we have in our brain is something that's at the bottom. Well, yeah, that works for most things, but with respect to a triangle, and we define the idea of a base, it can be any of the sides. It does not have to be just the bottom side. The height is a segment perpendicular to the base to the opposite vertex. It's a segment that's perpendicular to the base and drawn to the opposite vertex. So now that we have defined two things, we can now utilize our idea of an area as 1/2 base times height. But we had to define these two things first. Well, what we have over here is we have triangle bend. Okay, triangle bend here. Let's label our sides. Big E, side opposite big E is going to be little e. Side opposite big B is going to be little b. Side opposite big N is little n. Okay, sides opposite the lowercase of the uppercase letter. And just to get our mindset different, out of our bottom has to be our base. I'm going to make side E our base. So if I'm going to draw my height then, I need to draw a segment to the perpendicular to my base to the opposite vertex. So I've drawn in my height here. Now to calculate the area of this triangle, the area of this triangle would be 1/2 times E, which is our base, times our height H. But the problem is, H is in the middle of this triangle. Typically, we're not given that distance between the vertex point perpendicular to the base. We're not given that. So we want to make things a little bit easier ourselves, how we can manipulate what we have in our information here to be able to calculate the area of this triangle without having to draw in that H. And I can use lengths of sides and measures of angles. Well, by definition of a height, it's a segment perpendicular to the base to the opposite vertex. What we have formed here, when we drew our height in here, is we have formed right angles to the side E. And we've done that by just utilizing the definition of what the height is. Height is segment perpendicular to the base. So here we are perpendicular to the base. Well, for perpendicular, that means we form a 90-degree angle here. That's what we did. Well, the nice thing about that is we have created, once again, two right triangles, just like we did with our law of cosines. We created two right triangles. Well, what we want to take a look at, first off, is we want to look at right triangle number, we go number 1, that's fine. Right triangle number 1. In right triangle number 1, we have this segment, and here is our height. So we have our height here. We have angle B up here, which is an entire angle B right here. This angle and this angle are the same. We have point E here, but it's not an entire angle E. And what we want to do is, just like we did with the law of cosines. With the law of cosines, we want to create relationships between measures or lengths of sides and measures of angles of the original triangle. We don't want to have to deal with additional manipulation. So when I say point E, that's not an entire angle point E. That's only part of point E. I have part of E here, but it's not the entire E, okay, because E extends on downwards. But what we do have is this side N, which is the entire length of the side of the original triangle. So if we take a look at what we have entirely of the original triangle, we know an entire angle B here and here. We have an entire N and an entire N here. We also know we have a right angle here, which creates a right triangle. Well, what we want to do is we want to create a relationship that involves this angle B and this little n, that we know the entire length, and this h. So now we go back into our memory and going back to, once again, our definitions of sine, cosine, or tangent. Which one of our trig ratios would relate angle B to little h and little n? The sine. The sine of angle B is equal to whatever what, Brianna? H over n. So multiplying both sides by n, what we are left with is h is equal to n times the sine of angle B. So we have the entire length E, because that's our base, but now we have just said h, this height can be calculated by n times the sine of angle B. So making a substitution, this area is equal to 1/2 E times, I'm going to substitute in for h, n times the sine of angle B. which allows us to use two sides of this triangle that we know entirely. We know N and we can know E, and we have the angle B up here, which is an entire angle. Well, just like the law of sines, we can also manipulate this into different equations. Let's take a look at triangle number 2. That's rough. That's a little better. Triangle number 2, we have our right angle there. We know an entire angle N, which is this angle here. We know an entire length B, which is this side down here. Here is our H. This point E, we only once again know partial, just like we know up here is partial. So once again, we could go back and ask ourselves, which trig ratio, once again, would relate angle N to H and B? Sine again. The sine of angle N is equal to, once again, H over B. We can multiply both sides by B, so H is equal to B times the sine of angle N. So up here, we can write a second equation. Area is equal to 1/2 times, once again, our base is still E. But now subbing in, we have B times the sine of angle N. Here would be a second equation to calculate the area. Now, just like with the law of cosines, we have 3 equations that we can write for the area. Let's evaluate and let's follow the pattern. The first area we calculated was 1/2 E times N times the sine of angle B. The second one is E times B times the sine of angle N. So we want N and E sine of angle B. We want B and E sine of angle N. Well, we use angle B, we use angle N. If we follow our pattern, what would be our third one? Well, when we had angle B, we multiplied N and E together. When we had angle N, we multiplied E and B together. Well, when we have angle E, which two sides do you think we need to multiply together? N and B. N and B? Why do you say N and B? You're correct. Let's take a look at, I'll leave you off the hook here. Let's take a look here at, we want angle B and angle E and sine of angle N. Well, let's take a look at the relationships between those two sides that we have and the angle that we're using. We had EB angle N. We have NE angle B. And same as said N and B and angle E. What's the relationship between those two sides and that angle? They're adjacent, and they're right next to each other. Or what we call that is those two sides form that angle. Those two sides, B and N, form angle E. B and E form angle N. N and E form angle B. So those are the two sides that form that angle. what that is called by definition is the idea of the angle included, and this is a geometry term. The angle included is the angle formed by the two sides of the polygon, by definition. But we're going to specify a little bit more, just a triangle. So when we talk about the angle included, we talk about the angle formed by those two sides. So for any triangle, the area is equal to 1/2 times the product, bless you, one-half times the product of two sides. That means you're multiplying the lengths of two sides together, times the sine of the angle included. So we have the product of any two sides. So we take any two sides we want, multiply them together, multiply that by 1/2, and then multiply by the sine of the angle included. Then we don't have to draw in the height or the altitude and manipulate through the triangle and calculate the height. So area of any triangle, 1/2 product of any two sides times the sine of the angle included. Which now leads us to what is called the law of sines. We have the law of cosines. Don't want to leave out the law of sines here. They don't be left out. Sines don't. No matter which way we calculate the area, we should come up to the same area. We have 1/2 En sine of angle B. We have 1/2 Bn sine of angle E, or 1/2 Be sine of angle N. No matter which way we calculate the area, we should get the same area. Well, these things all should be equal. So if we use our multiplication property of equality, we're going to multiply both sides of our equal signs all by 2. So when we multiply by 2, this 1/2 goes bye-bye. So we're left with E times N sine of angle B is equal to B times N sine of angle E, which is going to equal B times E sine of angle N. We're just multiplying through by 2, getting rid of the fraction, because we don't like to deal with fractions. Now, we have said this shape is a triangle, which means if you have a shape that's a triangle, none of the sides have a length of 0. You have to have length to any of the sides. Because if one of those sides is 0, then you don't have a triangle. So B, E, and N has to be a value that's greater than 0. They cannot equal 0. Well, when we say it can't be equal to 0, that means we could divide by the product of Ben. If B, E, or N had a chance of being 0, we couldn't do this. But it doesn't have a chance of being 0 because we're saying this is a triangle. So if we look now we have all multiplication on top and on bottom. If we have all multiplication on top and bottom, things will cancel. E's and N's will cancel here. The B and the N will cancel here. The B and the E will cancel here. Leaving us with the sine of angle B over little b equals the sine of angle E over little e, which is equal to the sine of angle N over little n. Which gives us and leads us to what is called the law of sines. For any triangle, the sine of the angle, the ratio of the sine of the angle to the length of the side opposite will be in proportion. Okay, when you have ratios here, ratio is just a fancy way of saying a fraction. You have a number compared to a number. You have a number over something else. It's just a fancy fraction. When we put these fancy fractions equal to each other, we call them ratios that are put in proportion. So for any triangle, the ratio of the sine of an angle to the length of the side opposite will be in proportion. And that's what we have here. Sine of angle B over little b has to equal sine of angle E over little e, which has to equal sine of angle N over little n. So let's look at triangle Timmy here. Triangle Tim. Once again, not going to be too fancy with my triangles. They all look the same. You label how you want to label. We have triangle Tim. Sides opposite are your lowercase. Put your lower cases in. We are given the measure of angle T is 40 degrees. We're given the measure of angle I is 60 degrees. We're given little I is a length of 10. All right, before we start throwing numbers in here, what I want you to write using our letters of our triangle, using the letters of our triangles, write 3 law of sines proportion ratios. 3 law of sines ratios for our triangle that pertains to our triangle. Once again, do not feel that you have to do all these things all at one time, because it will lead to mistakes, to problems that, all right, if you're bucking for a grade, you need a grade in this class that is going to help out your grade overall in this class. This is the test right here. Okay, so if you try to do too many things at one time here, you're going to make mistakes, and when you make mistakes, your opportunity for a grade that you may need for this class is going to start to dwindle a little bit. So just the KISS principle, keep it simple. The sine of angle T over little t, sine of angle I over little I, sine of angle M over little m. Those are your 3 law of sines ratios. So if we take a look here, I know angle T, I know angle I, and I know little I. So I know these 3 values here. So what we can do is just look at these 2 ratios and solve a proportion. So let's rewrite, substitute our numbers in here. Once again, don't do too much at one time here. Let's substitute our numbers in. What's angle T? What's angle I? What's little I? How do we solve proportions? Cross multiply. We diagonally multiply. Some people say cross multiply and divide. That's fine. We'll look at that. We have 10 times the sine of 40 is equal to t times the sine of 60. We want to solve for t. We got multiplication by the sine of 60. So to get rid of that multiplication, we have to do what, Zach? How do we get rid of multiplication? Divide. So we cross multiply and then we divide. So once again, in our calculator, what I would suggest you do, you close your parenthesis out when it adds one parenthesis. You can clickety-clack in there. 10 times the sine of 40. Close your parenthesis out, divided by sine of 60. Close your parenthesis out. Clickety-clack, clickety-clack. Go out to 2 decimal places on this. Check your answers with somebody around you. Go 2 decimal places with it. Kaylee, what do you come up with? 7.42. Yes, no, maybe so? Go with that? Yep. All right. So that finds little t. Now, I know 2 sides here. I cannot use Pythagorean theorem, though, because I don't have a right triangle. Okay, so we have to go back to square one here. Well, we want to find little m. Problem is, we don't know big M. But if I look at my triangle, what's the measure of angle M have to be here? I have one angle is 60, I have one angle is 40. London, what's our third angle? Angle M have to be 80 degrees. Using that property of the sum of the angles of a triangle, I have to add up to 180. So now I know this also. Now my suggestion to you is go to the ratio that you know the values of. Because if you go over here, we solve for angle T. Well, if you boofed up angle T, that means angle, or little t, that means angle M is going to be bad. Okay, so go to the values that you know. I know I know big I, little I now know big M, solve for little m. So write yourself for proportion and solve for little m. So you should have sine of 60 over 10 equals sine of 80 over m. Cross multiply, divide. Find little m. Go 2 decimal places once again. Create for somebody around you. Again, you can multiply 10 times the sine of 80, close your parenthesis out, divide by sine of 60, and hit enter. And poof, it will come out for you. Dallas, what do you have?
15.32.
I'm sorry, what?
15.32.
Yes, no, maybe so?
I don't think so.
No. Rachel, what do you come up with? 11 point what? 37. Yes, no, maybe so? Good with that one? Okay, just recalculate it. 11.37, little m. Let's see, T was 7.42. Okay. Now, what I want to do, last part of this, is we're going to calculate the area of this triangle. Now, this section over here, I want you to use angle T to calculate the area. Middle section, you're using angle I to calculate the area. Over here, last section, you're using angle M to calculate the area. Okay, so you have angle M, angle I, angle T. I want you to calculate the area. Okay, so once again, if you look at the front side, area is equal to 1/2 times the product of any two sides times the sine of the angle included. Well, I gave you the angle that you need to use. You need to now multiply the product or multiply the two sides that include that angle and multiply by 1/2. Once again, I give you the angle to use. You have to multiply the sides, the product of the two sides that basically form that angle. Now, these should be close to being exact just because of us rounding and our rounded values here. You're not going to be totally exact, but you should be close to the values.
No? So you can't, I thought it was like, so you can't use the side? The sides that make the angle? Oh. I may have done that.
So angle T, what do you get over there, Chloe? 36 point what? 54. Angle I. Brandon, what do you get?
36.58.
Angle M, what do we get, Trenton? 36.54. All right. Once again, we're going to be off a little bit by a couple pennies here just because of our roundings. And that's okay. Show me what you're supposed to be doing, and you'll get credit for it. Questions that you have? All right, on page 229, you have 1, 3, and 5. Those three problems deal with the area of a triangle. Problems 232, 233, 1, 3, 5, and 7. Those four problems deal with the law of sines. So you have 7 problems. 3 of them deal with just area. The last 4 deal with the law of sines. Okay, tomorrow what we'll do is we'll combine everything together, all sides and cosines, and start solving through problems and triangle sets. All right, questions? Alright, QED, I was done.